All right, in this problem, the diver is making a 1800 Newton meter torque or turning effect with respect to A support of the board. And we are supposed to find out the mass of this diver. How many kilograms is the mass of this diver? So in order to do so, we need to use a model. So we need to use a model. This is the fulcrum, which is A. Here we have another support which exerts FB upward, and then here we have mg of the diver, which makes the turning effect of 1800 Newton meters. So we want to find out, and the distance here is 4 meters. So we need to find out this mg by using a simple equation of torque is equal to Rf, or moment of force. We can say is equal to 1800 Newton meter must be equal to mg times 4. And we need to take mg 9.8 meter per second squared, or almost 10 second squared. By solving this equation, we will get m is equal to 45.9 kilograms, almost 46 kilograms. So is the mass of this diver. So this is the first part of the question. But the second part is asking calculate the FA and FB if the diver has the mass of 52 kilograms. So in order to calculate this part, we need to part A, so we need to use a model, and the model of the seesaw model, or a beam. So therefore we will use this. There is a person, 52 kilograms, acting mg here, and this part is support B, and this part is support A. The problem says ignore the weight of the board. So therefore, in part B, the force is acting upward. So FB is acting an upward force on the board. Okay, but part A, support A, the board is, because this person is making a turning effect, okay, with respect to B, and if we just imagine B as a fulcrum, so the board wants to detach. The board likes to detach upward. So therefore, A, support A, must keep it down. So this will be FA. This support will keep the board and will act a force on the board towards down. Right? So let's write the distances from here to here, 3 meters. Therefore, from here to here, 4 meters to part A, and here is 1 meter. And that's it. We don't have anything else. So we use the second condition of equilibrium. Well, if we take the part A as the fulcrum, and the logic behind that is because we want to actually remove one of the unknown to be able to solve the problem easier. So if we set the fulcrum here at this point, therefore FA will not appear in our calculation since it does not make any turning effect, because the distance is 0, is directly perpendicular to the fulcrum, so it does not make any turning effect. And also we have got rid of taking into consideration or our calculation FA. So therefore we set the fulcrum here, part A, or pivot of fulcrum. So therefore we just take into account the turning effect. So this mg is turning clockwise turning effect, whereas fb is making a counterclockwise. So this is clockwise, and counter. So we say that's minus mg times 4 meters plus fb times 1 meter must be equal to 0. So mass here, the mass of the person here is 52 kilograms, and then g is 9.8 meter per second squared, or 10. Doesn't make that much difference. By solving this equation, we will get fb is equal to 2000 38.4 newtons. So this is FB. We have found FB. Now, how to calculate FA, or the force acting from the support A on the board? So in order to calculate that force, we can use the first condition of equilibrium easily, which is an easier way. Sigma Fy must be equal to 0, right? Therefore, forces heading up, positive, forces heading down, negative. Therefore, Fb minus Fa minus mg must be equal to 0. And FB, we have got it, 2038.4 Newton minus FA and minus mg, which is 509.6 Newton, will be equal to 0. And then we will get the answer. Fa is equal to 1528.8 newtons. So this is the value of Fa, which acts from the support A to the board. You may say that, okay, we need to just use the second condition of equilibrium and we don't want to switch to the first. Well, you can, and that is, you may use this second condition of equilibrium, sigma m, or the sum of all the moment of forces or turning effect must be equal to 0. And then you may draw the same diagram, FA here, FB up, and then we have an mg of the person weight, and we set the fulcrum at this point. Then we will calculate the turning effect of this and this force with respect to this fulcrum, which we set at here. We set the fulcrum here at the point, at the tip of the board where the person stands. Then we will get the same answer. So we might get the same answer, right? So this is part A. And part B asks, take into account the board's mass of 28 kilograms. In order to solve that, we will follow the same procedure as part A, exactly the same, but we need to just take into consideration the force, the mass of the force of weight, which is made by the mass of the board. And how to do that, we will just, okay, part B. Let's do this part B. In part B, we are taking into consideration the mass of the board, which is equal to 28 kilograms. So we will use the same, exactly the same model here. So we have the same model, and let me draw here, same model. We have FA towards down, we have got FB, and from the middle of this part, this beam or the board, we have 28 kilograms times 9.8 meters per second squared, which will be equal to 274.4 newtons. And then we have the mass of the diver here, which is 52 kilograms, and the force will be equal to 509.6 newtons. So at this point, and then we want to find out the value of FA and FB. What is the value of these two? So again, we will set A as a fulcrum. So we will set A as a fulcrum. Therefore, we just take into consideration all the clockwise and anti-clockwise moments of forces. So in this case, sigma m, or the sum of all the turning effect, must be equal to 0. Say FB, and the distance from B to the fulcrum is 1 meter. The distance from the center of mass to each side is 2 meters. From FB to here also 1 meters. All right. Okay, then FB times 1 meter must be equal to 27, this moment of force created by this, which is clockwise, 4.4 Newton times the distance of this force to the fulcrum, which is 2 meters, plus the moment that this force, the force of the weight of the diver makes with respect to fulcrum A, 509.6 Newton times 4 meters, and then we will get FB is equal to 2587.2 newtons. So this is FB. All right, and also in order to find FA, we can use the first condition of equilibrium, which states all the forces towards y-axis must be equal to 0, the sum of all forces actually, and those heading down to the south negative, those heading up to the north positive. So the answer will be, if we use this rule, this first condition of equilibrium, minus Fa minus 28 kilograms G times G minus 509.6 Newton and plus Fb must be equal to 0, and we have already found Fb, so we need to replace it here. So then we will get Fa is equal to 1803.2 newtons. You may say that, okay, that's the answer. You may say that, how about if we want to solve it with based on the second condition of equilibrium? So in that case, you may choose the middle of the fulcrum, the beam, as the fulcrum. So we just set the fulcrum as here, the middle, the place that the force 28 kilograms times 9.8 meter per second square is acting, the weight of the beam. And then we set this equilibrium at the middle, and then we have one Fa, one we have Fb, and then we have the weight of the person or diver, 509.6 Newton, and we have the distances to the fulcrum. So this weight of the beam will be cancelled out because it does not make any turning effect with respect to itself. So therefore we can use the second condition of equilibrium, and we will get the same answer. The answers will be the same in that case. Okay, thanks for watching this video.